Alright, this video is 3.6a. In the 6th edition, it would be 2.6. And it's on combining functions. And we often take functions, particularly our basic functions, we combine them to make totally new functions. We'll look at doing it algebraically in this video, and then in class on Tuesday in class next time we'll talk about graphically. We'll practice doing it on a graph. So first of all, we want to look at adding, subtracting, multiplying, and dividing. And basically we would write it like we could just write f plus g, or we could write f plus g of x is another possibility. Either one of these will work. It's probably clear from the context that this is a function in x, so you don't have to do it with this extra one. When we add them, or subtract them, or multiply them, well, or divide, any of them, we just exactly do what it looks like, okay? So f plus g would be f, whatever f is, plus whatever g is, and then we simplify. So we'd probably write this in the standard order with x squared plus 2x plus 5, because we add the 3 and the 2 together. Okay, so this would be our new function. If we were going to subtract, we would take whatever the first one was, and we could subtract either way. We could take g minus f, that would be fine. I'm going to subtract the whole function. We've kind of done that before. That means we have to distribute that negative, right? So it's going to be 2x plus 3 minus x squared minus 2, and when we simplify that, we get negative x squared plus 2x plus 1. All right, if we are going to multiply, we just multiply them. So we would have 2x plus 3 times x squared plus 2, and we distribute that all out. Some of you might call that FOIL. So 2x times x squared, that would be 2x cubed. And 2x times 4 would be, times 2, so that is a 4x. And then 3 times x squared, that would be 3x squared plus 6. If I were going to write this in order, I'd probably put the 3x squared in front of the 4. And division would be, just like you might think, 2x squared, 2x plus 3 over x squared plus 2. So let's talk for a minute about domain of this new function. So obviously the two functions both have to exist. You can't just have one or the other. So we can take the intersection of the domains. The only thing in addition to that is on the division one, the denominator can't be 0. So in all of these, now the domain of f of x is negative infinity to infinity. The domain of g of x is negative infinity to infinity. So that's going to be all of these, f plus g, f minus g, f times g. Now f divided by g, we look at the denominator one, g, and we see if it can be 0. and it can't, because we're working in real numbers, not imaginary. So g can never be 0 because there's no square that would equal -2. So this one is still going to be all real numbers. Okay, so let's do a different f and g. So first of all, we would just add them together or subtract them or multiply them or divide them the same as before, right? Now let's just do the domain. The domain of f, as you can see, the domain, the bottom can't be 0, so it would be from -infinity up to -1, -1 to infinity. Okay? That's a union. Okay, now for g of x, not quite so clear, but we do have that 2x plus 7 must be greater than or equal to 0. Jeez. All right, so when we solve this, we get 2x is greater than or equal to -7 and divide by 2. So in this one we have everything including -7/2 up to infinity. Okay, so let's look at where the intersection is, okay, because they both have to be true. We go from -7/2 up to infinity for g, and for x we have like everything up to -1 and everything after that, right? Okay, so where do they overlap? Well, they overlap from here to here. Of course, they don't overlap at -1 because f doesn't exist at -1. And then we go from here on, right? That shows where they overlap, where they're both true. So the domain of these combination ones would be from -7/2 to -1, but we won't include -1, and then up to infinity. Okay, so if we do f plus g, if we do f minus g, or g minus f, if we do f times g, or g times f, this is going to be our domain. So when we do f divided by g, or g divided by f, we have a slightly different domain. So when we do f divided by g, we have to make sure that g isn't 0, because we're dividing by it, right? So we already solved this greater than or equal to 0, so all we really need to do is make this not an equal to, right? It can't actually equal it. So that would mean that we would not include -7/2. Okay, everything else would be the same. Now let's look at what happens if we do g divided by f. So now it's f that can't be 0. If you look up here at f, it can't be 0 anyway, because the top would have to be 0 in order for that whole fraction to be 0. So this domain stays the same as our original one. There aren't any changes in it because the one on the bottom can't be 0. Alright, now let's look at these two functions. F of x is 3 plus 1 over x, and g of x is 4 minus 1 over x. The domain of both of them is everything except for 0. Right? So if we combined that domain, right, it would still just be everything except for 0, because that's the intersection, that it takes it all into account. Okay, well, let's see what happens when we do f plus g. All right, so we have 3 plus 1 over x plus 4 minus 1 over x. And we have that 1 over x and negative 1 over x, so this whole thing equals 7. So, it's a constant function. So what's the domain of that? Well, we would think that it was anything. But remember that domain has to come from the original function. So domain comes from before we simplify. So the domain is still negative infinity to 0 and 0 to infinity. Now, if we were going to graph this, it would, here's our 7. It would look like this line, right? It's a constant function. But the domain does not include 0. So I would have to put a little hole at 0. I would have to put a little hole there, so it would be this straight line, but it didn't include 0. Because this function written coming from these functions does not include 0. So that's what we're doing with adding, subtracting, multiplying, dividing. You really just add them or divide them or subtract them, whatever. And then the domain has to be the intersection of the two. Okay, here's your quiz question. For the functions f of x equals 1 plus 1 over x and g of x equals x over x minus 2, I want you to find the domain of f minus g. So you should write down the function and then find the domain. But in your answer, just write the domain in interval notation. Don't try to write the function. I don't even know how you would necessarily write. Well, just don't write the function. Just write the domain in interval notation.